guys, in the last video I revealed the entire Monsters Incorporated for my graduation project, but that was graduation project 1. For my second graduation project, the idea was to build the first ever Monsters Inc. running game. So let's get right into it. The first thing, I opened up Unity and make a new project. I will call it Monsters Inc. running game and hit create project. It will take a few minutes to open up. The first thing to do, we have to import the environment that we did in the last video. Let's put it in our scene and check everything. Everything seems fine. There are no problems. Everything imported perfectly. Now, let's light up our environment by adding some directional lights. Make duplicates out of them and scatter it around our environment to make the perfect scene. Now the time has come to add the textures that we made in Blender in the last video. First, the Monsters Inc. logo for our billboard. Second, the left side walls texture. Third, the right side walls texture. And the fourth, the wood texture. We won't also forget about Boo's door texture. To organize our lights, we will create an empty game object and put all our direction lights to it as a parent. Let's create another empty game object and add a box collider to it, so our player can have something he can run over, and adjust the scale right. And let's call it ground. Now let's add our player. Add the capsule and reset its transform component and put it where the game launch will begin. Let's add a material to it, reference it in the scene and choose red color. Let's create an empty game object and call it a player, reset its transform, copy the component of the capsule and paste it into the player so they match each other. And let the player parent the capsule, remove the capsule collider and add it to the player, adjust the collider, add rigid body to it, and let's see if it's working. I will adjust the ground box collider a little bit. That seems fine. Now, let's cover up all our environment with the ground. Now, for the logic of the game, we will create a C# script and call it a player. Open up Visual Studio. I wrote the script hands before, alive to check if we're alive, speed of the game, the rigid body, the horizontal input, horizontal multiplier, and the speed increase per point, and the grounded to check if we're on the ground or not. If he's not alive, then we don't want the player to move. Forward move, we move our player forward, and the horizontal move, we take the input that we gave it in the update, and if we press space, it will jump and set the ground to false. If we press Q, it will rotate our player, and if we fall below -5 on the Y, it will call the die function that will invoke our restart method that would restart our game from the beginning. And there's a void on collision method that will bring information about the object which we collided with. If the collided object with the tag called ground, then set the grounded to true. Let's save our script and reference the rigid body component of the player to the script. And let's test our game. Dude, where are you going? There's a slight issue in the rotation. Now let's test it. Much better. Let's test the game by maximizing our scene. There's another problem. In the player, we have to freeze the rotation on the X, Y, and Z. Perfect. Now let's move to the camera. Let's copy the transform component of the player and paste it into the main camera so they match each other. Let's move our camera and rotate it to the right angle. Adjust the positions. Let's create a C# script and call it the camera. Open it in Visual Studio. I wrote the script hands before. There is a player variable that will store the transform component of the player and offset, and boolean is returned. When the game starts, it will subtract the position of the camera to the player's position and store it in the offset. When is returned is true, the vector 3 target pose will store the player's position plus offset, and XY of the target pose I set them manually. The transform position of the camera will be the new target pose that we just made. Also, when we press Q, the camera will be rotated and is returned will be false. When is returned is false, I made a new target position, and this time I set the 3 positions X, Y, Z manually. Let's save the script and let's reference the player's transform to the camera script and test our game. It seems good. Let's move the position of the player a little bit. There's a problem here. Because I can jump only once, the grounded variable remains false. It never resets to true. Because we forget to put the ground tag into the ground game object. Now it should work. Much better. Let's speed up our game to test if the rotation in the third section of the game works. It is good, but needs an alteration in the rotation of the camera. Let's test it again. Very good. I think I should remove the decimal point and leave it at 13 and save the script. Every game needs a character. To make a character, you need a modeling software. For this game, I made Sully using Blender. And to make a character in Blender, you have to go through the 4 phases: sculpting, retopology, UV unwrapping and painting, animation. So, let's open up Blender. I started blocking out the shape of the character and using Blender's sculpting tools, and after 3 days of hard work, I got here. The time has come to add an eye to the character. Add the sphere, adjust the scale and the rotation, and put it in the right place. After that, link duplicated to the other eye. I made the horns and link duplicated. And the sculpting phase has been finished. But after this phase, there is a big problem will arise. This character is high poly, like look at the number of the faces. It's above 1,300,000. We have to reduce it as much as we can. Now the second phase, retopology. Link duplicate the character and the duplicated version, we want to remesh it. What exactly remesh means? Removing all the high detail that you put in the sculpting phase by reducing the number of faces, how you specified in the remesh property. We have both versions of the character now, one high poly and the other one low poly. They are top of each other. You can see the detail that has gone from the low poly and fix it. This process took a long time because retopologizing a character is not an easy task. But why retopologizing a character is so important? Because think of it as this: if you want to animate the high poly character in the animation phase, for example, if you put a bone in the shoulder, perhaps that shoulder has 50,000 faces. Therefore, if you animate it, it will crash Blender immediately. And the high poly is not optimized for the game engines. After the retopology phase, our character looks much cleaner and the number of faces has been reduced. So let's see how much it reduced. Almost 80,000 faces. Still not a good result, but will work just fine for our game. The third phase, UV unwrapping and painting. But what does it mean? Mark the seams of the character and then unwrap it, because if you didn't do it correctly in the painting phase, the colors may intersect each other in the texture. For example, we painted the face green. The green may also appear in his back. That's why UV unwrapping painting is very important phase. The fourth phase, animation. I made many animations using Adobe Mixamo. 4 of them will be implemented in the game: running, jumping, colliding, and falling. Let's back to Unity and export the character to the game engine. Let's put our character in the scene and make him child to the player. Copy the position and the rotation of the capsule and paste it to our character. Adjust the position a little bit. Let's add the character's texture to the engine. Now let's test the game. Wow, it looks horrible. I'm kidding. Let's adjust the position of the camera a little bit. Much better. Our character implemented perfectly in the engine. Let's create animator controller for our character and put the 4 animations we mentioned earlier: running, jumping, colliding, and falling, and making the running animation the default one. Now create on the character animator and reference animator controller on it. Since it is a running game, we have to enable the loop time on the run animation and apply it. Works perfectly. Now, let's make the transition between the animations. Let's create a Boolean parameter and call it jump, and set the conditions on the transitions. When we want to jump, the condition must be true. When we finish jumping, the returning transition must be false. Let's get back to Visual Studio to write some code. We need a reference to our animator and call it anim. When we press space bar on the keyboard, we want to transition to the jumping animation, so set Boolean true. And when we hit the ground, we want to transition back to running, so set Boolean false. Let's reference the animator from the character to the player script and test the game. Okay, the wrong animation played. At least he is jumping. That's because we forgot to uncheck the has exit time on the transitions. Now it should work. Sully looks small in this game, so let's adjust the scale and move him a little bit. Adjust the position of the camera and test the game. Awesome. In the next video, we'll add the obstacles, the coins, making levels, and continue finishing up our game. Thanks everybody for watching and have a good day.